medicine, a crucial question is, does this cause that? Does a habit lead to disease, or does a new drug truly cure illness? The answer isn't always obvious. Correlation does not equal causation. Just because two things happen together doesn't mean one caused the other. Mistaking correlation for causation can have serious consequences for public health and medical advice. To navigate this complexity, we use the Bradford Hill Criteria, a set of 9 principles to help determine if a link is truly causal. Think of them as a detective's toolkit, not a checklist, but a guide to building a strong case. Before these criteria, it was easy for industries to cast doubt on scientific evidence and for studies to contradict each other. The criteria give scientists a common language to evaluate evidence and move from observation to action. Understanding these principles isn't just for scientists, it empowers everyone to make informed health decisions. When you see a headline about a new health risk or benefit, these are the principles experts use to assess the claim. Knowing them helps you judge the strength of evidence behind medical advice. To understand the Bradford Hill Criteria, let's go back to the 1950s when lung cancer rates were soaring. Many suspected smoking was to blame, but the tobacco industry argued it was just a statistical association. Sir Austin Bradford Hill and Richard Doll conducted landmark studies showing smokers were far more likely to develop lung cancer. But Hill knew strong data alone wouldn't convince everyone. He saw the need for a clear framework to evaluate causation. In 1965, Hill introduced his 9 criteria, not as rigid rules, but as a guide for thinking about causation from multiple angles. This framework helped the medical community cut through industry misinformation and take action against smoking. The criteria became the intellectual ammunition for public health campaigns and policy changes. Hill's work showed that establishing causation isn't just academic, it's essential for protecting millions of lives. The story of smoking and lung cancer is a powerful reminder of why we need rigorous standards for causation. The Bradford Hill Criteria remain vital for evaluating health risks and guiding public health decisions. The first criterion, strength, looks at how strong the association is between exposure and outcome. For example, heavy smokers were 15 to 30 times more likely to get lung cancer than non-smokers, a massive risk increase. Strong associations are harder to dismiss as coincidence, while weak ones require more supporting evidence. The second criterion is consistency. Has the association been observed by different researchers, in different places and at different times? If dozens of studies worldwide find the same link, like smoking and lung cancer, the evidence becomes compelling. Consistency means the finding isn't just a fluke or due to a single study's design. When results are replicated across populations, our confidence in causation grows. For example, the link between HPV and cervical cancer has been shown consistently worldwide, leading to the HPV vaccine. Strength and consistency are the first clues in building a case for causation. They help separate real risks from statistical noise. The third criterion, specificity, asks if a single exposure leads to a specific outcome. This is strong evidence in infectious diseases, like the measles virus causing measles, but less so for chronic diseases. Smoking causes lung cancer, but also heart disease and stroke. Lung cancer can have other causes too. So specificity is helpful when present, but its absence doesn't rule out causation. The fourth criterion, temporality, is essential. The cause must come before the effect. You must show the exposure happened before the disease developed. This can be tricky in some studies, but long-term cohort studies help establish the correct timeline. For example, to prove a diet causes weight loss, the diet must start before the weight loss. Temporality is the only absolutely necessary criterion for causation. Without it, we can't be sure what's cause and what's effect. Prospective studies are crucial for establishing temporality in medical research. These criteria help clarify the direction of cause and effect. The fifth criterion is the biological gradient, or dose-response relationship. More exposure should lead to more effect. For example, the more cigarettes smoked, the higher the risk of lung cancer, a clear dose response. This pattern is hard to explain away as coincidence. We see dose response in many areas. Higher medication doses lower blood pressure, more sun exposure increases skin cancer risk. The sixth criterion is plausibility. Does the association make sense biologically? When smoking was linked to lung cancer, scientists knew tobacco smoke contained carcinogens that could damage lung cells. Plausibility grounds statistics in biology, but it depends on current scientific knowledge. Sometimes what seems implausible today becomes accepted tomorrow, as with H. pylori and stomach ulcers. Dose response and plausibility add weight to the case for causation. They help ensure that findings aren't just statistical quirks, but fit with what we know about biology. These criteria make the story of causation more convincing. They push us to look for both patterns and mechanisms. The seventh criterion, coherence, asks if the causal claim fits with what we already know about the disease. For example, the smoking lung cancer link matched lab findings and historical trends. If a new claim contradicts established facts, we should be skeptical. Coherence ensures our understanding is logical and consistent, not based on isolated findings. The eighth criterion is experiment, often the gold standard. Randomized controlled trials, RCTs, can provide strong evidence by directly testing cause and effect. But RCTs aren't always possible or ethical, like assigning people to smoke. In those cases, we look for natural experiments, like whether quitting smoking reduces lung cancer risk. Experimental evidence, even from prevention trials, strengthens the case for causation. Coherence and experiment help us build a narrative that fits both data and biology. They ensure our conclusions are grounded in reality, not just statistics. These criteria are key for making confident, science-based decisions. The ninth and final criterion is analogy. If a similar relationship is already accepted, it makes a new one more plausible. For example, knowing thalidomide caused birth defects made it easier to accept that rubella could too. Analogy is useful for generating hypotheses, but it's one of the weaker criteria. Still, it can guide research, as when scientists look to other viruses to understand HIV and AIDS. Today, the Bradford Hill Criteria are a cornerstone of epidemiology and public health. They force scientists to be rigorous and consider multiple angles before making recommendations. For doctors, these principles underpin evidence-based medicine and patient care. For the public, understanding them helps combat misinformation and encourages critical thinking. The criteria help us ask the right questions and demand strong evidence before accepting health claims. Understanding causation is central to medicine and public health. The Bradford Hill Criteria provide a lasting framework for turning observation into life-saving knowledge. They remind us that causation requires more than a single study. It needs a body of evidence from multiple perspectives. This approach underpins everything from clean air laws to vaccine programs. These guidelines ensure our actions are based on sound science, not speculation or special interests. For individuals, this process gives confidence in medical advice and empowers better health choices. The criteria are about clarity, responsibility, and turning data into action. In a world of complex health challenges, this framework is more important than ever. By demanding strong evidence for causation, we protect and improve human health on a foundation of scientific truth.